talking about amines, a functional group that everywhere from our brains to our cleaning supplies. So we have our two experts here to help us. From biological science, Cherry, and from applied chemistry, Sebastian. Welcome both of you. So how are you today?
Well, we're doing great, Sheena, and very excited to be here.
Same here, ready to talk about amines.
Awesome. Our audience is already excited too. Okay, so let's start simple. Cherry, what is amines?
Well, amines is the easiest way to think about that. Amines come from ammonia, which is NH3. Just replace one or more of those hydrogens with a carbon group and you have an amine.
So what are primary, secondary, and tertiary amines?
That's just a count of how many carbon groups are attached to the nitrogen. So one carbon group is primary, then two carbon group is secondary, and three carbon groups is tertiary. It's just tell you how basic the nitrogen is.
Got it. But Sebastian, what about the lone pair of electrons on the nitrogen?
That lone pair is the key. It's not a bond, so it can grab a proton, hydrogen ion from another molecule. This makes amines bases. That one simple fact is the key to almost all their functions.
Okay, so they are basic. But let's put their properties to the test of property showdown segment. First, boiling points. Cherry, why does propan-1-ol alcohol boil at 97 Celsius while propan-1 amine boils at only 48 Celsius? They have similar molar mass, right?
Well, they have both hydrogen bonding, but oxygen is more electronegative than nitrogen. This makes the OH bond in alcohol more polar than the NH bond in amine. So the alcohol hydrogen bonds are stronger, so it makes heat to make it boil.
Also, it makes sense. Sebastian, your turn. Solubility challenge. Why are small amines soluble in water but large ones aren't?
Okay, every amine has two parts. The polar amine had negative NH2, which is hydrophilic, it loves water. The non-polar carbon tail, which is hydrophobic, it hates water. With small amines, the polar head wings and pulls the molecule into water. But when the polar tail gets too long, past about 6 carbons, it wings. The molecule becomes too oily and won't dissolve.
Wow, that's a great explanation there, Sebastian. Now let's talk about the big so what. Cherry, where do we find amines in our bodies?
Well, they are the building blocks of life. From the amino acids, DNA, and RNA. In the amino acids, the amino part is our amine group. They build all our proteins. In DNA and RNA, the bases like adenine and guanine are amines. They form the rungs of the DNA ladder.
But what about our brains?
Well, that is the coolest part. Many key, the neurotransmitter are biogenic amines. You have heard of them like dopamine and serotonin. Well, in dopamine, it's our reward and motivation molecule. And serotonin regulates mood and sleep.
Incredible! So, Sebastian, if amines controls our mood, it makes sense that drugs will target them.
Okay, exactly. Many pharmaceuticals are just amines. For example, stimulants like amphetamines. They force to release neurotransmitters like norepinephrine, making you feel alert, and pain relief. Analgesics like morphine and anesthetics like lidocaine are also amines that block pain signals.
I heard that these drugs are injected as salt. Why?
That goes back to basicity. The drug molecule is oily and not water soluble. So chemists react the basic amine with an acid. This forms an ammonium ion salt. The salt is charged, so it dissolves perfectly in water for injection.
So smart. And I have last question for you, Sebastian. Why does ammonia clean grease so well?
Basicity again. Ammonia in water creates hydroxide ions, OH negative. Grease and fats are acidic. The basic hydroxide ions react with acidic grease and break it down so you can wash it away. kay itong mga amines nga giingon sa itong chemistry?
Ha, asa? Ang amines kay organic compounds maguni siya gikan sa ammonia. So, kung ilisan nimo ang usa or pila ka hydrogen atoms o carbon groups niya, maamin na siya.
So, more ang ammonia ang nagpaglow sa atuan from plain hydrogens to classy carbon vibes. Wow.
Oh, sakto. Depending sa pila ka hydrogen na gi-replace na atay, primary, secondary, o tertiary.
Yeah. Pero unsa may gamit ana sa biology?
Daghan kaayo man na amines, naa sa amino acids, o kana maoy building blocks sa proteins, maunang without amines, wala gyud tay muscles, enzymes, or even skin.
Hello, so wala ka ng amines mga taguan, jellyfish tanan?
Pwede, pero wait. Naapa. Amines po naa sa neurotransmitters like dopamine, serotonin, and adrenaline. Muna sila ang nag-control sa atong mood and energy.
So kung kapoy kayo po, amines dahil ako pasalamatan.
O,
Either.
kung ma-excite ka or mahatlok, like kung makakita ka baki, ay mong adrenaline and yung aning hormone.
Well, sure. Uy, so if every time mo masyagit ko kayo, makalita ko like ka ng ipis or like cockroach, amines na kami siya?
Di naka-arte. Chemical reaction, hindi na. True, well, amines po makita sa vitamins and probiotics so bisan sa bananas. Maong maka-feel ka gamay na mood, bows ko, mukhaon ka usapin.
Pero wait, Cherry, ba na may amines na like ako kayo?
Like, putrescine o caliverine. O, nasa ito ka na hinungdan bako sa pain sa isda or patay na.
Ew, so from love chemicals to baho cakes, grabe ka versatile.
Mao gyud. So in short, kana ang amines kay makatama na siya pag una kung kanang feel o kanang grow o usahay mabaho.
So wow, after all your explanations, let's do a recap. Amines are basic and that one property makes them essential for our DNA and proteins, our mood and brain function, life-saving medicine, and even cleaning our windows. They are truly chemistry and sound heroes. And now, that's all our time for CHEM CONNECT show. A huge thank for you, Cherry and Sebastian.
Thank you as well.
Thank you, audience, for also watching us. Goodbye. See you tomorrow. Bye.